Okay, so we talk about secret sharing, Shamir secret sharing, which is basically a TN threshold secret sharing scheme. TN threshold secret sharing scheme by Shamir. So basically, there are n users or n participants, and there is a group manager. So let us. So there is a group manager or the leader, dealer or something, and there are n users. So U1, U2, UN. Okay, and now there is a secret key or the session key, because this need to change by session wise. Suppose this is a, for example, suppose this is a TV channel operator, a cable operator, Tata Sky or some cable service provider, and these are the users who subscribe for this channel. Okay. So now this cable operator will broadcast something, some movie or something. So that movie, that is the movie or something. So that movie need to be encrypted using a key. So that key is a session key, because it has to change, because some user may get revoked. If I am not paying the subscription, I have to be I will be in the revoked list of the this thing. So this K is the session key. So now this question is how we can share this key among the users, so that when the T user, there are n users, so that K be the key. This is the secret key. Okay. So the question is how we can share some information with this user, so that when T user come together, then they should be able to recover the key. So that is called TN threshold scheme, TN threshold secret sharing scheme. So there are n users. If the T user come together, then they should be able to recover the this secret key. So what is the scheme? So scheme is basically, so group manager or the dealer will choose a polynomial fx of degree t minus 1. So just like this, a1 t, and putting this f0 as k. So a1 t, a2 t square, sorry, a1 x, a2 x square plus a t minus 1 to the power t minus 1. So t minus 1 degree polynomial. Polynomial. So the group manager or the dealer will choose a t minus 1 degree polynomial and put this k as a constant. So that means f0 is basically the secret or the secret key, which we are going to share among the n users, so that if t users come together, they should be able to recover this secret. Okay. So how we can do that? So this is a t minus 1 degree polynomial, and so there are how many constant? There are basically t constant. So now suppose these are the users u1, ui. So ui will, so group manager will give some secret to the ui, the secret or the shared of ui. So what will be the shared of ui? So either ui and this AIs are coming from, this key is basically ZP star, and this AIs are also you are taking from ZP star, where P is a prime. So, ZP star is basically ZP minus 0 where P is a prime. So, ZP star is a cyclic group under the multiplicative operation. P is prime. So, it is ith user, either we choose a ID of this. So, ID also should be belongs to ZP star, or we can convert into some we can use some mapping, or we can simply use I. So, this is the say I is the ID for simplicity we take this I is the ID of UI for simplicity, but it could be anything, I mean it could be any ID, and then we have to convert into the 0 on string or in element in ZP star. Okay. So, then this will send the ID to GM. So, while GM will do, GM has the polynomial, GM has chosen the polynomial. So, GM will compute this f of I and send this f of I to in a secured way. So, this is the share of this. So, UI has this share I f of I, or it could be if xi is the ID xi f of xi in general, but for the simplicity we can take the I f of I. Okay. So, this everybody has. So, this is 1 f of 1 for user 1, 2 f of 2. So, similarly un has n f of n. Okay. So, now, so this is their share. Their share is basically a point and the value of the polynomial at that point, and that point is basically their ID, or they could choose any point or by their own. So, now how they can now compute k? So, now this is a polynomial of degree t minus 1. Now, suppose n users, suppose t users come together with their shares. So, these are their share. Now, if t users come together like UI1, UIT, let this be a group of t users. This is TN session scheme. So, if a group of t users come together, they should able to get the secret. So, this is the aim of this TN threshold secret sharing scheme. So, now if they come together, how they can get the key? So, this means they know the value f of I1, I2, f of I2, IT, f of IT, f of IT. So, these values are known. So, we have a polynomial of degree t where there are degree t minus 1 where there are t many unknown constant. So, now we can use some interpolation formula like we can use the Lagrangian interpolation formula, because these points are not equidistant. So, Newton may not work here because these points are basically their IDs. So, we do not know which group of users are coming together. So, they are not equidistant. So, one can use the Lagrange interpolation formula to find out the to get the whole polynomial. Lagrange's interpolation formula to get the polynomial or f of 0, polynomial value at 0 to get f of 0. So, so this is basically k. So, k is revealed. So, if the t users come together with their polynomial value at their points, then we can solve the we can use the Lagrange interpolation formula to know the whole polynomial. So, whole polynomial is revealed. So, this is the basically Shamir T and threshold secret sharing scheme. So, it has application in visual cryptography and broadcast encryption. So, in visual cryptography, can you go to the slide please? So, this is basically KN threshold scheme, where a secret S is divided into n pieces. Suppose this could be an application in banking system. Suppose we have a locker. So, in a locker in the bank locker, a key is with the group bank manager and a key is with the user. So, when they together meet, they should able to open the locker. So, that is the secret sharing. So, locker key is the secret. So, we are sharing into we are giving the share to the bank manager and the users. So, when they come together, they are able to open the locker. So, here this is a KN threshold scheme. So, we are divided the secret S into n pieces such that if the k users or more come together, they should able to recover the secret. But if there are k minus 1 or less user are coming, then they should not able to recover the secret. So, this is an example, simple example of 2 threshold scheme. Suppose this is the secret image and we want to share between 2 users, and when the 2 user will be coming together, then they should able to. So, this is the secret image. So, this is the share for 2 users, share 1, share 2. So, now by seeing this picture, nobody can guess that was the symbol of IIT, logo of IIT Guwahati. Now, this is also this thing now, but if they come together, if we just merge these two, then this will be like this. Okay, superimposing this share 1 and share 2 like this. So, then it will be a then it will reveal the secret. So, this is this has a application in visual cryptography. Now, we will talk about some application in like broadcast encryption for Shamir secret sharing scheme. Okay, so, in broadcast encryption, we have a group manager. The broadcast encryption is basically one to many. Okay, so for our encryption, I mean a public key in public key, suppose we have many users like U1, U2, we have many users U1, U2, UN, and suppose we have a group manager. We have a group manager, and group manager wants to send some message to these users. Now, for so far we know one-to-one encryption. That means everybody is having their private key and the public key pair. So, U1 D1, E2 D2, EN DN. Okay. Now, if some message has to send to U1, so what we do? We just this is one to in the general public key setup, in the normal public key one-to-one public key encryption. What we do? We suppose this is the message. So, we just encrypt this to send to U1. We will just encrypt this message using the public key of U1. So, it is basically encryption of M U1, and similarly this. So, for UI, it is basically EIDI is the corresponding public key private key pair. So, this is basically encryption of UI M. So, that means this is, so this ciphertext size is very big. So, these all this has to combine, and moreover this is one has to get their corresponding ciphertext, that means this. So, this is a huge bottleneck of this. So, instead of that, so this is one-to-one corresponding. So, in broadcast encryption, what we will do? we do one to many. I mean, we want to send the ciphertext, broadcast the ciphertext in a single go, and then the person, legitimate user, should able to decrypt it. So, how we can use this Shamir secret sharing scheme for this purpose? So, let us just so this is group manager and these are the users U1, U2, UI, UN, and suppose this is the secret key. Group manager wants to share between shared to this user, so that, and this is the set of revoked users, say revoked users. The revoked user set, say I. So, UI1, UI2, UIK. Suppose this is the set of revoked user. So, revoked user, now we want to send the message in send the broadcast the ciphertext in such a way such that revoked user should not get the information what is the key. Now, this is suppose the session key for time being. Now, this session key we want to share between this, so that revoked user should not get the session key, because this session key is be used to encrypt the movie if it is the cable line operator, this GM. So, this will be used to encrypt the movie. So, if the revoked user, that means who did not pay for the movie or unsubscribed from this channel. So, he or she should not able to get this movie. Okay. So, what we will do? We just group manager will compute a polynomial like this. First compute a revoked polynomial, which is Rx, is basically by taking the indexes of x minus ik, okay, and compute f of x, f of x is a t minus 1 degree polynomial. So, that means f of x is some a0 plus a1x plus at x to the power t minus 1 degree polynomial. So, this is also T-n threshold scheme we are discussing, but in a broadcast encryption in the so there are revoked users. So, we do not want we are not allowing revoked user to get some information. So, what we will do? We just so then GM will compute this. This is the session key k and masking with the revoked user polynomial plus f of x. Okay. So, this is the polynomial, this okay. So, this is the polynomial, it is calculating. Now, so GM is calculating this polynomial f of x, h of x, and this is also a t degree polynomial. So, h of x is computing okay. Now, suppose the user is joining in the initially. So, f of x is also with the, so both are t degree polynomial. So, this is the UI users. So, what UI is having, what GM is giving to UI at the time of registration, it is giving us f of UI. So, f of I basically. So, this value it is having. So, identity, I mean, or ID of I, f of ID of I. So, this value it is having. Okay. So, now so this is this value it is having. So, now what GM is doing? So, GM is broadcasting this h of x. So, GM is broadcasting this h of x. H of x is basically k of r of x plus f of x. So, now this user is getting h of x. Okay. Now, this user is getting h of x. Now, upon getting h of x, what this user can do? User need to get the session key k. So, user can compute h of ID, because h of x means the polynomial, whole polynomial GM is broadcasting. So, it is a t degree polynomial. So, basically it is broadcasting the t points on this polynomial. So, anybody can do the interpretation using the Lagrange to get the whole polynomial. So, anyway, so this person, this UI can calculate this. So, after calculating this, and also it is broadcasting the revoked user set. So, what are the things it is broadcasting? This polynomial along with the R. R is the revoked user indices. Okay. So, from here this user UI can compute R of x. R of x is basically x minus I1, x minus I2, x minus Ik. So, basically it can compute R of ID of this. So, once it has this and it has f of ID of I, because this is the secret which is already it is having. So, it can simply now compute. So, we know the h of x is basically k r of x plus f of x. So, the h of ID I, or it could be just I to simplicity, but ID should be an element from ZP star. Anyway, so k r of IDI plus f of IDI. So, from here k is basically h of IDI minus f of IDI by divided by R of IDI. Okay. So, this is basically, now this value user is computing by because this value, this polynomial is broadcasted by the group manager. So, this value can be computed by the user, and this value it is having, and this value also can be computed by the user, because this is his ID is not belongs to the revoke list. So, this value also can be computed by the users. So, by doing this calculation, user can get the session key k, but the problem will be the revoked users, because for revoked user they will try to put their value over here with their ID. Their own ID is basically either of these. Suppose a user say KL, say KI, KI is a revoked user, sorry I1 is a revoked user. So, if we try to get this value, then this part will be 0, because this will be 0 for any value, for revoked user value this will be 0. So, this will not give us the corresponding the secret key because of this revoked user. Now, this scheme we can make it to the TN threshold scheme, because this polynomial, if we know this polynomial, if we know this polynomial, if say suppose so if somebody knows this polynomial f completely, then he or she can able to get the session key, because we know the h of x is basically k r of x plus f of x. Okay. Now, if we can calculate some value j, say h of say x j for some j, provided this r of x j, this will not be belongs to in the work set. Then from here one can calculate r of x j. So, that means if the t users is coming together, then because this polynomial f polynomial is of degree t. So, if the t user is coming together, then they can compute this polynomial or polynomial at some point, and then they can easily get this session key. So, this can be extended for a TN thresholds secret sharing scheme also. Okay, thank you.